Yep. Okay. So, do you guys have the document open for the preparation assignment?
Um, so, yeah, I have all the documents open.
Sehr gut.
Huh?
So, then let's just get on the first question. So the
Fine.
Graduate Management Admission Test, GMAT, is used as an admission criterion in many Masters of Business Administration MBA programs. The scores on the GMAT in the past have a mean score of 529. BYU professor feels now that the score has just improved within the last couple of years. Determine the null, I mean, null, whatever, and alternative hypotheses. So, the null hypothesis would be,
Would be the 529, right?
Yeah.
well,
And then the alternative would be that the mean is greater than that number.
Oh yeah.
Okay.
that's right. That's what he believes because it's not a matter of it's not equal to that number. It's you know that that's what he's assuming that it's greater. So,
Mhm.
righty. Suppose that you've got evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking exam is still 529. Was a type 1 or type 2 error committed?
I just type 1 because the mean is the mean is still 529, but it was rejected anyways.
Yeah, you need to fail to reject it, right? According to the reading. So, yeah, I agree. It's type 1. Does that make sense, Veronica? Were you able to get the reading? Or
To some of it, not all of it.
yeah. So it's basically a type 1 error is when you should have rejected. No, wait. It's rejecting the null hypothesis when you need to keep it.
Mm.
It's kind of confusing. I need to find a good way to memorize it. All right. If the analysis was done at alpha equals 0.01 level, what is the probability of committing a type 1 error?
Yeah.
Is
1%.
that just 1%?
I will take your word for that. I don't know exactly. What's your
I also have the answer sheet up so we can look at it.
that makes sense though, because 0.01 is 1%. So,
Mm-hmm.
Yeah.
but so is it always just the decimal represents?
I don't know. I mean, I think for now, I need to relook up the lesson.
Yeah.
Let's go ahead and move on to D.
Okay. If we wanted to decrease the probability of making a type 2 error, we need to increase or decrease the level of significance?
Um, we need to increase it. Because like the lower the percent, the lower the chance of getting a type 1 error. But at the same time, it would equal a greater chance for the type 2 error to happen. So that's why they made it 0.05.
Good. So basically, what you're saying is the lower the percent, the less likely type 1 will occur.
Yeah, at the very least, I think I remember that. I'm not sure. I do remember that 0.05 is what they usually use. and then also point, I guess, 0.1, but mainly 0.05. Let's see. Okay, so the typical values are 0.05, 0.1, and then 0.01.
So 10%, 5%, and 1%.
So go ahead,
Yeah,
move on to 2.
in the reading it says that the prob wait, if the value is very small, the probability of committing a type 2 error would be larger. So if we go with a 0.05, it means that you have more the probability of committing a type 1. Is that correct?
So I think
I,
what Clayton was saying is that if it's a 0.05, that was larger than 0.01, so if it's larger, you're less likely to commit a type 2 error.
yeah.
So I think
But you're
0.05
more
is
likely
larger.
to commit a type 1 error the higher it is. So
Did you freeze? Still alive?
I think he froze again.
He's frozen. Just like Elsa.
it's ideal.
I know, right? Sorry. Clayton, are you still there?
Yeah.
Okay, cool.
Can you hear me?
Yeah, you were frozen for a second. Alrighty. Number 2, a study. Did we get everything resolved from the previous?
Did we get what now?
Yeah.
Did we get everything resolved from the previous question? Okay, I think we're good. So, a study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Assuming the national standard deviation was 5, the real estate agent wants to determine if the average age of those buying investment property in this area is different than the national average. He selects randomly 15 of his clients who purchased an investment property and obtains the data shown. So those are ages, right, in the boxes?
Yeah, I think so.
So design the study. What is the population from which the realtor obtains his data? How did he sample this population? What is the research question? Okay, start with what is the population from which the realtor obtains his data?
It's from the second home buyers, isn't it?
From the sorry?
Hmm?
Couldn't quite hear you, Veronica. What did you say?
Well, it says according to the report, the average of the person buying a second home on the investment property. So wouldn't it be them, the second home buyers?
Yeah. I think the nationwide one, right? Like the nationwide is the population. Nationwide, what you said, nationwide second home buyers.
Mm-hmm.
Does that make sense? Do you agree with that?
Yeah.
I guess it would be. I mean, the population is definitely second home buyers, but I don't know national or not. I think it is.
Well, I think it's national because then the sample are also second home buyers, but they are in just his specific area. And it's these 15 numbers that we have above. That's what I think.
Okay, so how would they sample it?
Yeah. Let's see. He randomly selected. I guess that's how it says.
Yeah. I think so too. What is the research? But
Research question is.
What's the people buying, isn't it?
he wants to.
Yeah, what is the average age of
Um,
the people buying homes? Second homes.
yeah.
What is the average?
It says it in the fourth sentence.
Okay. What is the average age?
Okay, wait. What happened? You guys kind of freeze on me.
Oh, I'm sorry. So we asked, what is the research question? And we believe it is, it's this. So what is the average age of second home buyers in America or in his area?
Okay. So we're gonna go on B already?
Yeah, sorry, I'm just looking at this one real quick. Oh, okay. Okay, cool. Collect the data. Name at least one way a realtor could have randomly selected his sample.
I'm guessing that might be simple random generator.
Yeah.
Would be a good one to use for this.
What is that exactly? What did you say?
Simple random generator. That's where like it uses a computer to just randomly select anybody.
Oh, cool. So you could have just like assigned someone a number and then assigned all of his clients a number and then pushed randomly select 15 times or something.
Mhm.
Cool. That sounds like fun. All right, describe the data. Graph the data on a histogram. Sketch the histogram below, or cut and paste your electronic copy. In short paragraph, describe the data using at least 5 descriptive statistics. Oh, we could do.
Well, we don't have to paste it, but I mean, I think that's pretty much. We'll just take this data right here
Oh, you know what I could do? I don't even need
and put it in.
That's that one chart thing, right?
Yeah, the quantitative descriptive statistics.
Yeah.
Um, I'm trying to see if there's like an undo a button. Oh, there it is. Okay, there. So I don't have to open up a new one. I think it could be. Again. Yeah. Okay, I'm just gonna have to enter it manually.
Yeah.
Let's see.
I can't really do this on my
Looking for something. No, I'm making. I'm trying to get that too, huh? It's the not the red one.
549.
Let's see.
Okay, let's see. So I forgot what it's called, but it looks like multiple something. What's it called? Like where it doesn't actually, like it has like two or more peaks.
Oh, oh, really? That's what it has? I don't know. What is that called?
What do you mean 2 or more peaks?
Like, it's not just left skewed or right skewed. It has two towers, kind of.
Oh,
It mainly
isn't that
looks
just the normal
like
one?
it. No, norm is like bell curve. It's kind of looking like it wants to bell curve, but it has two peaks on it.
Huh. Let me find out. Let me make a histogram real quick.
Okay, so let me take a look. Okay, I'm looking it up now, and it's like chapter 3. Um,
Isn't it just the?
so it's multi
Huh?
or multi-model.
Hmm.
But I guess it's still considered bell maybe. Or no, model.
No, I think it's the one you said first, the multi.
Well, I'm looking at it like right now, and there's like uniform bimodal, and my model has two peaks, and the multi-model has four peaks on here. So let me see the definition. If
Oh,
there are more than two peaks, it's referred to as multi-model. So it's bimodal.
yeah.
Oh, and then it says right here, there's two distinct peaks. It's called bimodal. So let me take a look. What else? Where am I?
It kind of
Oh, okay.
So yeah, it looks like
It honestly kind of looks left skewed, doesn't it?
yeah, yeah, it kind of does.
It
I mean, it
looks,
has to
it
take.
kind of looks like it would like wants to be, but at the same time, it looks like by model. I'm not sure about that. It's not entirely too important for this one since it's just homework. Um, let's see.
So
Um, Short paragraph describe the data by using at least 5 descriptive statistics.
oh, doesn't that mean the minimum, maximum, third quartile, first quartile, median?
Yeah, I think
Uh,
so.
But you have the my computer is not capable of some of those things. But the minimum is obviously 27. Right? 27?
Mhm.
Yeah.
What is the first quartile? You have that open on that Excel spreadsheet?
Yeah, it's 41.5. Right?
Um. Oh, what is it again? Sorry.
41.5. The first quartile, right?
Yeah, the first quartile.
Yeah.
Good, sounds good. Mm, Um, the median is, what's the median?
46.733.
Is that the median or the mean?
Oh, I'm sorry, that was the mean. The median is 49.
I was gonna say I was expecting like a whole number. I was like, I wasn't expecting
Sorry.
a big one. But the third quartile,
Third quartile is 53.
the maximum is
58, right? Is that the highest one? Yeah, 58.
So let's go ahead and move on to D1.
check the requirements. Since there are only 15 pieces of data, what would you need to check?
I'm not sure on that. I guess wouldn't we be trying to check if it's normal?
Yeah.
What makes you say that?
I don't know. I mean, that was just kind of a guess. I mean, because like one thing we need to check is like if the mean's going to be the same as the population mean. And for that, it either has to be a normal distribution or it needs to be a large sample size.
Mhm. I like that.
Um,
What else? Let's see. State the null and alternative hypotheses. Is one or two?
so, so the answer sheet says that for D1, make a QQ plot of the data and check for normality. Um, Anybody remember how to do that?
I'm guessing just plot the dots and see if it follows a line.
Oh, yeah.
But I are you trying to figure out that graph?
I'm looking it up and how to make it.
Don't you just plot the like the birth, like the not the birth. You just do a graph, don't you? And you plot the ages of where it goes, and then right there it'll show you if it's going straight, like in a line, or if it curves.
Yeah.
Oh, hold up. So if you go to quantitative descriptive statistics, it already does it for you if you go down to QQ plot.
Oh, really? That's nice.
Yeah.
What does it look like?
So it kind of looks like an S shape. I mean, it's close to the line, but at the same time, it's not. I don't think it's normal.
Hey, you should try something. Try pushing screen share.
What?
There's a
Screen
button
share.
on the side that says screen share. I'm just curious to see if it'll work.
Let me see.
Screen. So where do I go for screen share?
Hover over the video screen where you can see our faces, and the green button. On mine, it's the second one from the top, or second. Yeah, second one from the top.
Oh, okay. Here we go. I'm guessing this. Start screen share. Maybe that's.
Oh,
So cool! Okay, Clayton,
cool.
keep talking because we need to see that. Clayton, say something so it switches you.
Can you see mouse moving
Hello?
around
Clayton?
around the graph? No.
No, that's
If
great.
if you if you click on him on his thing where it says, like where it says the little box on the bottom, you
Yeah.
can go on the screen.
Okay, yeah, I just saw that. I just did that. Yeah, I can see your mouse moving. Haha, this is so cool.
Yeah,
That
I
is
can
cool.
see the.
I'm happy about
I
that.
can see where the blue highlight is, but can you see my actual mouse?
No,
Yeah.
I can see your mouse. I can see the blue highlight, like you said.
Oh,
Same.
okay. So I
Oh,
would
yeah,
have.
thank you.
that.
Because now I can see what exactly it looks like. Perfect. So, yeah, I don't know. What do you think, Veronica? Do you think that looks normally distributed?
Yeah,
You think so? Follow
yeah,
along.
it's curved enough, I think. As
Do you
it
think
goes up,
It does
goes.
curve. It does curve out, but then it comes back in. It could be normal.
Yeah.
What is Clayton? I can't quite read it. What does the horizontal axis represent, and what does the vertical axis represent?
Let's see. It does not say entirely. No, it does not say.
Hmm.
What the x-axis is? Let me take a look at something. Do you know? There's no legend or anything.
Hmm. Oh well. Let's see. Well, I think I don't know. I can't tell. It's. I think it could be normal because it starts in one place and ends in the same place.
I guess it would be normal. Let's go ahead and move on.
Yeah.
Um,
Do you know how to get out of that?
yeah, I've already done it just now.
Oh, I still see.
There, he's there.
Oh, I just see a different thing. Alrighty. Cool.
So state the null and alternative hypothesis.
The null hypothesis. Sorry, I keep saying that in a weird way, but it's the null. The null hypothesis is.
Basically, it's that the average person of buying a second home as an investment rental property was 47 years. And what the guy wants to figure out is a real estate agent wants to determine if the average of those buying investment property in this area is different from the normal average. So
So that
basically, the alternative hypothesis is that it does not equal 47. So this would be two-tailed.
yeah, I
What do you
think I
guys
agree with
think?
that. I agree that it's two-tailed. No hypothesis. Here's-
Okay, so there's nothing we have to answer for number 3 because that's just telling us to put the level of significance right there. I gotta go to the bathroom real quick.
Well, we can do the other one, right? Because we have to find the z-score.
Yeah, we can do it. Sorry, I was just trying to fix something on mine.
No, that's fine.
I missed
Okay.
it. Good. Cancel. Okay. Compare the test statistic. What is the formula to be used? It would be z equals x naught, bar x, minus the mean over standard deviation over
The square root of.
square root sample size.
Mm.
Is that it, or is it the other one?
Other what?
No, that one's it.
That was it? Gosh.
Okay, so let's see. Oh, right. I should use this.
Okay. Alrighty. So what do we need to do here? Part of mine is I can't see because of the format of the computer. Like on number 3 where it says let something. After let, I can't see anything at all.
Let alpha equal 0.05. We don't have to answer anything for that. It's just telling us to use that as the level of significance. I don't think we're at that point yet. I think we're just calculating the z-score.
Okay.
One question I have is, do we use the standard deviation of the national, or do we use what we just got from the data?
Well, I think it's from the data. I think you could do. Yeah.
Oh, I can look at this again.
Oh yeah.
Okay, so it doesn't tell us what to input on there, so it just tells us the answer, so we can look real quick, and that way we'll have will understand. So right now I'm starting with 5 divided by 15. Okay, so let's see. The z-score for doing that was, it looks like it's a bit different, kind of close, but different at the same time. Let me try the other way. 2, 6, using the data, 8, 7, divided by, oh, that's not it. Oh, hold up. I might have made a mistake in my previous one. Divided by, yeah. So basically, on the answer sheet, it's 0.2091, and I got negative 0.2068. So that's the closest to that number I got, even if it's in the opposite direction, negative. Oh, let me take a look at my notes real quick.
Well,
Okay, so basically we are supposed to use the first one, that's 5, for the because that's a population parameter, and the one that we got from the data would be the simple statistic. But I don't know why we're getting a different number.
I think, so did you do z equals z?
The mean minus the population mean divided by the population, the standard deviation of the population divided by the root of n.
Yeah,
And
yeah.
so yes.
You did that, and what did you end up with?
I ended up with the answer, it says, is 0.20910, but I got negative 2.068.
Did you put the bottom part in parentheses?
Yes, I did. Let me recheck again just to make sure. Yes, I did.
Yeah.
Okay, I'm confused. What's the... Okay, you know how the equation is the z equals... What's the x again?
The x with the line over it?
Mm-hmm.
Yeah.
That's the sample mean.
Yeah, what is that in this case?
The sample mean, from what it says on the chart that we made, it's 46.733 repeat, or 46.73 repeating.
So basically,
And the mean, it's the mean they give us, the 5? No, not the 5.
minus 47.
The 5, huh?
It's 46.73 minus 47, right?
Yeah, 47. And then that answer, you divide it by 5 divided by the square root of 15.
Oh. Let me put in my calculator, see what I got. So,
Oh, that is weird that it's a negative. Oh, wait, but...
because 40, maybe we're just doing the wrong equation now. 46.73 minus 47.
That might be a mistake on his part.
It could be, because, I mean, it is the right answer. Just not negative.
Yeah. Like I'm looking at the answer key and like at the very least the chart or the data input is 46.7 repeating on that.
Yeah, so it's the
Hold up.
Yeah, I think either way, I mean, that's just the z-score. It's going to be positive or negative when you put in the applet, isn't it?
Um, it is, but usually you start with the answer got like if it's negative, like you're looking at like for example over if you're looking like okay what's this is it greater, then you'd be looking at if say the z-score you got is -2, if you put -2 everything to the right of -2 you're going to get a different probability of everything to the right of 2.
Hmm.
um Oh, okay. So on the next one, it has the p-value. I mean, we could take a look at that real quick. I'll just open up the probability calculator, or what is it? Normal something. The normal probability applet. Okay, so let's see. Um, 2 or 0.2068. Okay, and then let's see. Hmm.
get 0.8344.
Huh?
Did you get 0.8344?
No.
Yeah, you have to make sure that you shade the sides, not the middle.
Oh, right, that's right. Let me put it into um 068. So I got 0.836.
Yeah, that's what the answer is.
Yeah. And then on the answer for the p-value, it's 0.8344. So
It's really close. I don't know.
that's close enough for our needs because it's not going to affect the answers to the questions that much, and it could be a um, for sketch. Okay, so yeah, we just did 5. So let's go ahead and move on to 6. And that is compare the p-value to the level of significance. Do we reject the null hypothesis, or do we fail to reject it? And since it's 0.84, I'm sorry,
It's bigger
since
than
it's
5.
0.836, it is not rejected.
Mm-hmm.
Is that what you guys got?
That's what I got.
Um,
No. Hmm. Why is that? So, does that mean we didn't
It's
commit a
because it's
type 2 error,
greater.
though, right? So we keep the null because it's
yep,
okay.
the null.
Yeah, because it's too big of a probability. Okay.
Uh,
State your conclusions in terms of the alternative hypothesis.
I don't think we can have one, right? Because it was not 47.
No, we can't. Well, basically, we can say that we can't. I mean, so far, we do not have enough evidence or so to reject the null hypothesis, which is we do not have enough evidence to reject that it is 47. I mean, the average age of 47.
I agree.
Okay.
What action, if any, do you suggest the realtor to take based on your statistical conclusions? Answers. Oh wait, I'm reading the answer. What action, if any, do you suggest the realtor to take?
Well, I would say that you continue to use data that, I mean, use that the average is 47.
No.
Like he can't say any otherwise yet. I mean, from what the data from his experiment is, he can't say that it is any different from 47. So he's just going to have to keep on using that number.
Otherwise, if he did reject it, if he did decide to keep like, I don't. It's true. Alrighty. So moving on to the quiz.
Okay. Just a sec. Okay. Okay, starting now. Okay. No, 21 questions. Let's see. It looks like most of it is multiple choice. We only have to put in 3 different answers for calculation. So that's probably why so many questions, and it'll probably be
Probably.
probably will go by fast. Okay, number 3, a hypothesis test consists of 2 hypotheses, a null and an alternative. Which one represents the status quo?
The null hypothesis.
Okay, I agree.
Which hypothesis involves equality?
Same, the null.
Yep, the null. Oh, the null. Sorry.
Wait, did it mention anything about true hypothesis?
Oh, no, I don't think so. I think that's just a.
I think that's just a throw us off.
Yeah.
Oh, because yeah, 3 says there's only 2 hypotheses.
Yeah.
So that's kind of dumb for number 3. The p-value is the probability of obtaining a simple statistic at least as extreme as one that was actually observed. Use this information to answer question 5. When computing this probability, which hypothesis do you assume to be true? Wouldn't that be the null?
Let's see. Let me. Read that one more time. You know which one it is, actually.
Ah, good. It didn't log me off. So what do you guys put for 5?
I am not sure. What makes you say it's the null?
Well, I think it's the null because, let's see. Which do you assume to be true? I'm sorry. Sorry, never mind, scratch that. Let me reread this. Um, uh, oh.
Let's see. The p-value is the probability of obtaining a sample statistic.
Oh,
And
so it might be the alternative.
when you mean, oh, wait a minute. It would be the null, right?
Yeah,
Because
I think it is because I think when you do the p-value, it has to be, since it's an extreme, it has to be the null.
right,
Oh, really?
you don't want to be biased. You don't want to assume that the um, alternative is true already, because that's what you're finding out, right?
Hmm.
So I think it's
Yeah.
alternative because if you were to look at the extremes, wouldn't that make it a low probability? And if it's a low probability, you reject the null hypothesis.
Man. Let me see.
But then you only reject the null whenever the p-value is small.
Yeah, we reject the hypothesis if the p-value is low
So
or
in this
low.
one, you're saying that if the p-value probably is obtained. Hold on.
Okay, I'm looking at the definition of p-value, and it says the p-value is the probability of obtaining a test statistic such as z at least as extreme as the one you calculated, assuming the null hypothesis is true. In other words, our p-value is the probability that we would get a z-score that is as extreme or more extreme than blah, blah, blah.
I think it's the null because it says it right there when you're computing this problem. Which hypothesis do you assume to be true?
I think it's the null as well.
All right, we'll go with that.
Sorry. Yeah, okay. So suppose the null hypothesis is mean equals 10. Use this information to answer the question 6 through 8. Which of the following represents the alternative hypothesis for a two-tailed test?
I think it's the third one because basically says it does not equal 10. So it can either be greater or less than 10.
I agree.
Yep.
Okay. Your thoughts? You agree?
Number 7 is which of the following represents the alternative hypothesis for a left-tail test?
Left tail.
I think that's the first one because then that would be less than 10.
Yeah, I think you're right. Let me look at the lesson real quick.
Wait, less than or greater than?
I'm pretty sure it's the
less
top one. The mean is less than 10 because if you think about it, 10's right here, and you go to the left, a number line, that's less. That's the way I think of it, but it could be
Well, it's
opposite.
like, I think it's like around the beginning that of the lesson that it says.
Yeah, I found it. I found it in the lesson, and it is. We were right. We're right. It is a left tail.
Okay, so let's see. So for right tail test, it would be the second one since that's the opposite direction.
Exactly.
And then, okay, so 9, the outcome of the hypothesis test is determined by comparing the p-value, significance, or alpha. Use this information for 9 and 10. Which relationship would result in failing to reject the null hypothesis? And that would be if the p-value was less than alpha.
See, I don't get that. I don't get. So if it's less than alpha, we fail to reject it.
No, I think we reject it. you take a look at the very bottom, it'll tell us levels of significance alpha is the standard for determining whether or not the null hypothesis should be rejected. Typical values for so on and so on. If the p-value is less than alpha, we reject null.
P-value is not less than alpha, we fail to reject the null. So if you read the question again, it says which relationship would result in failing to reject the null hypothesis.
Yes.
You got to put the p-value is greater than alpha, right?
No.
Or am I?
It would have to be low, because it basically says if the p-value is less than alpha, we reject the null.
Yeah.
So the p-value would have to be less than the alpha, and that's the second answer.
So it's the first answer?
No, it's the second answer.
Oh, yeah, but it says, read the question again. So which relationship would result in failing to reject the null hypothesis?
Oh, failing to reject. Okay, yeah, never mind. I was thinking reject.
Oh, yeah, no worries. I
Number
figured
10
that.
is the other one.
Yeah.
So then 10 is the second one and this one.
Yes.
And so number 11, an insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. This is for 11 and 12. So 11, which of the following would be appropriate alternative hypothesis? So I guess basically it would probably be the third one. The average claim amount is greater than.
And then for number 12, it's saying what would be appropriate for the null. Would that be equal, the first one?
Yeah. Yeah, I agree for 12 as well.
The insurance company randomly selects 40 claims and calculates a sample mean of x equals 1650. Use this information for questions 13 through 15. The insurance company assumes the distribution of the sample mean is normal. It's a good assumption.
Yes, right?
Mm-hmm. Yeah.
It's a greater number.
Yes.
It's a large number.
Yeah.
What was that?
I was just saying, yes, you're right, because of the central limit theorem. Because it doesn't tell us whether or not the parent generation is normally distributed, but we do know that the sample size is large, so it'll be normal.
So it's the central limit theorem, which answers 14.
Oh, haha! I am happy with myself.
Okay, so which one are we on now? 15?
Yeah.
Okay, which of the following is a test statistic as defined in this lesson?
It's Z, right?
I think so.
What was that?
I think we think it's C, the second one.
Test statistic. Oh, I'm pretty sure it's Z. The historical mean of sales at a grocery store is $150 with a standard deviation of $40. The store manager suspects that the average has decreased. That's a hypothesis test with the following hypotheses. The null is $150, and the alternative is she believes it's less than $150. We will use a level of significance, A equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes X equals $144. Use this information for questions 16 through 18. Okay, take the z-score, or z equals 144 minus 150, right?
Mm-hmm.
Over standard deviation
40
which is 30, yep.
divided by the square root of 36. And I got negative 0.9.
Okay, check that out.
Minus 150. 6 divided by 40.
Wait, what did you divide it by?
Okay, so it's 144 subtracted by 150 divided by 40 divided by the square root of 36.
I got
Yeah.
minus 0.9.
I did that. I got that too. Negative 0.9.
Yep, same.
Oh, I thought I heard you say something else. Sorry.
Okay, what is the p-value associated with the z-score from the previous question? So we highlight the left area, and then we put in negative 0.9. And I got 0.1841.
Oh, it's 3 decimal places though. Hang on.
What?
Wait, say what you got again?
I got 0.184.
Okay.
Wait. What did you get? I'm sorry. What did you get again?
Let's see.
You highlight everything to the left of that?
Yeah, because she basically wants to know, basically the store manager suspects that the average has decreased. I mean, and the alternative is the population mean less than 150?
That makes sense to me.
Oh,
Because
okay.
because the way I think of it, it's the alternative hypothesis is to the left, and it's to less than. So
So it's 0.816?
0.184.
Yeah.
184?
0.184.
That's not what I got. Well, I think I did something wrong.
Did you highlight only the stuff to the left?
Yeah. I got it now. I forgot that we were in the negative.
Hmm.
I highlighted it from the positive.
That'll be a lot more.
Yeah.
What inference would you make about the null hypothesis for this problem?
I think
Well, the p-value is greater than the alpha value. What that means we need to fail to reject the null hypothesis, right?
yeah.
Yeah.
I'm still sketchy on that one, so.
No, I think that's true. That's why I said. So 19, there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? I think that's type 1.
Agreed. So, a researcher decides that instead of using a level of significance of alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true? The probability of a type 1 error will increase. Probability of a type 2 error will increase. Probability that the null hypothesis is true will decrease. His experiment will be more scientifically valid.
I think it's the second one. I think it's the probability of a type 2 error will increase.
Because you'd be more likely to fail. Oh, that makes a lot of sense. Okay, I think I just got it. Because you'd be more likely to fail fail to reject the null hypothesis because no matter what, most of the p-values are going to be over 0.01. That makes sense to me.
Okay. So number 21, alpha equals 0.05. Compute the probability of committing a type 1 error.
I think we go to the probability applet, right?
Maybe.
Point
0.05.
Oh wait, we need to test the probability. That doesn't work. Unless, hang on. Yeah. Oh, I'm not sure this one. How would you figure that out?
I don't know.
I think you have to find the.
Sorry?
Hold on, I'm trying to see.
Huh. How on earth would you figure this out?
Oh, wouldn't it be 5%? Because hold up, like in the homework, of what I remember, let's take a look. I think one of the first questions we answered for that. Let's see, suppose melody, the mean score of taking this exam. If the analysis was done at alpha equals 0.01 level, what is the probability of committing a type 1 error? And it says there was about a 1 in 100% or 1% chance that there would be a 1% error, or I mean type 1 error. So this would be 5%.
Yeah.
Right?
What?
Yeah, I agree. Question though, I just tried typing in what you said. Tried typing in 5%. And it doesn't. The box doesn't let you type in 5%.
No.
Could
You
you
have
just
to put it in
0.05
decimal
then?
form, don't you?
I think.
Yeah, I agree with that.
Are you sure it's not 0.01?
What now?
Are you sure it's not 0.01?
Well, it's asking if alpha equals 0.05, compute the probability of committing a type 1 error. The homework says if the analysis was done at alpha equals 0.01 level, what is the probability of committing a type 1 error? And it says there was about a 1 in 100 or 1% chance that there would be a type 1 error. But this is not 0.01, this is 0.05.
I agree, because if you think about it, if something is greater let's see. If something is greater than 0.05, the
Oh, okay.
yeah. That makes it, I
I
didn't say
didn't finish
anything.
the homework. Sorry.
Okay, no worries. I was just about to explain something that didn't make any sense at all. So
So I am going to go ahead and submit and check it. So I got 100.
okay, cool. Great. Alrighty. Good job, guys. Only took us not that long this time. So try to meet next Tuesday earlier, but probably not going to happen. So meet as early as we can.
All right.
Okay, just let me know.
All right, cool. See you later.
Bye.
Okay. Bye.